part 2 of the Society of Freshwater Science Summer of Science is climate projections. Why do we need them? Here's why. To explain why, I like to use the analogy of the types of roads we have here in West Texas. This is a Google map of Lubbock, where I live, or Lubbock, as my Canadian family prefers to pronounce it. And as you can see, it is so flat here that we have roads that are pretty much dead straight. In fact, some roads, like this road leading north to Plainview, Texas, are so straight that you could be driving down the road looking in your rear view mirror, and you would stay not only on the road, but in your own lane. Why? Because where you were 5 seconds ago, 10 seconds ago, heck, 5 minutes ago, is a perfect predictor of where you'll be in the future. So when the road is straight, looking backwards is a great way to stay on the road. Now, I don't recommend it. There could always be something coming up in front. But if the road is straight, looking behind you offers all the information that you need to stay on track. Until when? Until just before you get to Plainview off the top of this map, you hit a giant curve in the road with a row of concrete grain silos on the curve. What happens if you are driving down the road looking in the rearview mirror? Let's just say that you end up someplace you didn't plan to be. Well, how does this connect to climate? Well, we know that wherever we live, we have wet and dry, we have hot and cold, that's just weather. But we don't often think about the fact that so much of what we do is based on the long-term average of weather, which is climate. Climate is the average of weather over at least 20 to 30 years. And although we can have hot and cold, we can have wet and dry, over long time scales, we assume it all averages out. This is what determines what type of species live where, how much the average water supply is. It even determines things like what type of crops we grow, where and when and how, our energy demand, our building infrastructure, and more. Unfortunately today, though, we know that climate is changing. The long-term average is tilting such that we still have hot and cold, we still have wet and dry, but long-term, decade by decade, the statistics of our weather are changing. So the first reason that we care about a changing climate is because it alters future conditions that affect everything, our infrastructure, our resources, our ecosystems, and more. But that's not all. We also see that as climate changes, it is stretching or distorting our extremes. It's making some of them more frequent, it's making others stronger, others more intense, or others all three. The second reason we care about a changing climate is because it exacerbates so many of the risks that we already face today, supersizing many of them and making many of them more dangerous. So how does this connect to the road? It connects to the road because we are approaching the curve. In fact, our wheels are already on the rumble strip. And rather than only looking backwards to make our decisions, we have to start looking forwards into the future. That's why we need climate projections to see how steep the curve is, how quickly it's approaching, and how, and even whether, we're going to be able to make it around that curve safely. So how exactly is climate change affecting our extremes? Well, we know that we are always vulnerable to naturally occurring weather and climate extremes. NOAA has this map of the number of billion-dollar weather and climate disasters. It's a very anthropocentric map because obviously if you don't have people, you don't have billions of dollars of damage. But what this shows is that state by state, we've had different numbers of disasters that have caused different amounts of damage. Texas, where I live, is number 1. And this is part of the natural risks that we face every day living on this planet. But what we see is that climate change is loading the dice against us. So we always have a chance of rolling a double six, a drought, a heat wave, a flood, a wildfire, a hurricane. If you live in Texas, you already have 3 6s on your dice. But decade by decade, as climate changes, it's as if it's sneaking in and taking one of those other numbers and turning one of those other numbers into a 6 or even a 7. And all of a sudden, we're rolling more 6s than we should, or even the occasional 7. And we say, how is this happening? It's happening because a changing climate is exacerbating our naturally occurring risks. Let me give you some specifics. And these specifics come from 2 sources. They come from Volume 1 and Volume 2 of the U.S. National Climate Assessment. Now, until the 6th assessment report for the IPCC comes out, and it hasn't come out yet, these 2 volumes are the most up-to-date and comprehensive summaries of the state of climate science that we have, both at the global scale and for the US specifically. Volume 1 focuses on global and North America. You can find it online at science2017.globalchange.gov. And Volume 2 focuses very specifically on the United States, looking at every region and every major sector. These things are huge. The second volume is 1,600 pages alone. But don't worry, it's not a novel, so you don't have to read it from beginning to end. You just pick the chapters that are most interesting and relevant to you, and I strongly recommend doing so because they are a treasure trove of valuable information. You can find Volume 2 online at nca2018.globalchange.gov. So what does the National Climate Assessment and what does the science tell us about weather and climate extremes and how they're being affected by a changing climate? Well, one of the first things we see is that heavy rainfall is becoming more intense and more frequent, and the connection to a warmer planet is pretty direct. Warmer air holds more water vapor. When a storm comes along, as it always does naturally, there's more water vapor for that storm to pick up and dump today than there would have been 50 or 100 years ago. So in many, not all, but many places around the world, we are seeing a very significant increase in heavy precipitation. In the United States, we are seeing the biggest increases in the Northeast and in the Midwest, although we are seeing it across most of the area except for the islands. It's not only about the water content of the air, though. We also know that extreme precipitation is getting worse when it's associated with not just normal storms, but big storms. Like what? Well, like the atmospheric rivers that hit the west coast of North America, all the way from California up to British Columbia and beyond, and the tropical storms, which we call hurricanes. In other parts of the world, they call them cyclones or typhoons, that hit our coastal areas in the tropics and the extratropics. Why is this kind of a 1-2 punch? Well, first of all, there's more water vapor for these storms to sweep up and dump on us already, and these are very powerful, strong storms. But unfortunately, we also see that, for example, atmospheric rivers are getting more intense in a warmer climate. We also see with hurricanes that they are intensifying faster because they get their energy from warm ocean water. More of them are stronger. We aren't seeing more hurricanes in total, but of the number we see, a greater percentage or proportion of them are stronger because they're being fed by that warm ocean water. They're moving more slowly so they can sit on top of us and dump more water on us. They're getting bigger. They're staying stronger further northward. And of course, we have the fact that sea level is rising, which not only increases the storm surge associated with coastal storms, but it also increases the risk of saltwater intrusion into freshwater or brackish ecosystems along the coast, many of whom require a delicate balance between saltwater and freshwater inputs. We know today that sea level is rising twice as fast as it was just 25 years ago. And Greenland, for example, is melting about 6 times faster than it was in the 1990s. Why is that important? It's important because in the past, thermal expansion, warmer water taking up more space, and land-based ice sheet melt. Of course, if the ice is already resting on top of the ocean, like in the Arctic, it doesn't matter if it melts, it doesn't affect sea level. But if it's resting on land, like in Greenland or Antarctica, and it flows into the ocean, then that does contribute to sea level. So in the past, those were the 2 different factors that contributed almost equally to sea level rise. But the rapid acceleration that we've been seeing has been caused primarily by accelerated melting of land-based ice in recent years and decades. You might be surprised that we didn't start this list with heat, but I think heavy rainfall and storms is very relevant to freshwater systems, and for some may have even a bigger impact than the direct impact of heat. But unfortunately, we know that heat is also increasing. Now, we still get cold waves, of course, but we know that heat waves are becoming more frequent, they're becoming longer, and they're becoming much more intense. In fact, we know that the heat wave season in the United States, which used to be just about 3 weeks long back in the 1960s, is now over 7 weeks long today. We also know that high temperature records are constantly being broken much more frequently than cold temperature records. We still break some of those. And in terms of loading the dice against us, here's a good example. The heat waves that Europe has experienced in the last 15 years, they've had 500-year heat wave summers in 15 years. Talk about loading the dice. You're supposed to have, on average, statistically, about one 500-year event every 500 years. Not 5 every 15 years. You see, the definition of what a 500-year summer is has to change now because it's more like a 1 in 3. We don't see, across North America, we aren't seeing more frequent wildfires because the ignition causes are often human ignition in the lower 48 states and in the southern part of Canada. Lightning is a major source of ignition in the rest of Canada and Alaska. We aren't seeing more frequent wildfires, but we are seeing that when they occur, they're burning a lot more area because they often occur in hotter and drier conditions. So, cast your mind back a while now to 2017, when in December, the Thomas wildfire in California broke the record for burning the greatest area. But that record was broken just 8 months later, in August 2018 by the Ranch Fire, and it was smashed in November 2018 by the Camp Fire. Then Alaska has been plagued by devastating wildfire seasons, both in 2019 and already in 2020, though we're not done. Wildfires in Canada have been the costliest insured disasters in the country. And at the beginning of 2020, though it seems like years ago now, the Australian bushfires were leading our headlines with the devastating impacts they had, over 1 billion dead animals, all kinds of health impacts, destruction of infrastructure, and countless more. It isn't that wildfires didn't already happen, but they weren't as big, they weren't as intense, they didn't move as quickly, and therefore they weren't as damaging. So when it comes to wild weather, the question is not, did climate change cause this event? The question is, did climate change make it worse? And often, not every time, but often the answer is yes. With wildfires, for example, we know that without a changing climate, there would have been probably about 12 million acres burned across the western U.S. naturally. But with a changing climate, there's been about 24 million acres, so double that burned since the 1980s. If you're interested in some fall reading, I highly recommend this book by Frederica Otto, who is an expert in what you call weather attribution. I just read it recently, even though it's not coming out until September, and it was fantastic. It's very accessible, very readable. You don't have to be a climate scientist to understand it, but it explains the field of attribution and how we understand, did climate change make something stronger, or did it make it more frequent, and if so, by how much? This type of work that Ferdy and others do actually explains how we know that climate change increased the rainfall associated with Hurricane Harvey by anywhere from 15 to 40%. Climate change made Europe's heat wave at least 5 times more likely. It actually shows how the numbers on the dice have been changing as a result of a changing climate. I think the Prime Minister of Dominica, which was one of the islands devastated by the 2017 hurricane season, really put it best. He said this. He said when he was speaking to the United Nations, to deny climate change is to deny a truth that we have just lived. Climate change is no longer distant and far off. Like coronavirus, it's not only happening on the other side of the world anymore, it's not a future issue either. It is here and it is now. And that's why we need to look at that curve in the road, because again, our wheels are already on the rumble strip. We are already entering that curve, and the question is, will we make it around safely?